Okay, 2.2, we are going to continue graphing parabolas, but we are going to graph them in forms other than the vertex form. So for today, we're going to graph it in this format, which is standard form. Standard form is highest degree to lowest degree. Since it's quadratic, it starts with ax squared. The a value still indicates whether there's going to be a vertical stretch, a shrink, or a flexion of the x-axis. Okay, to find the vertex in standard form, to find the x-coordinate or the h, we do negative b over 2a. To find the y-coordinate, we take our negative b over 2a and we plug it back into the original equation. Other fun facts is the y-intercept is going to be the c value over here, and that's because if I plug x as 0 in here, I get a times 0 plus b times 0 plus c, which gives me c. So it'll always be that last number, just like slope-intercept form. Okay, let's try example 1. Okay, now look at the format first. This is standard form. Standard form means I can't just graph it really quickly. I have to use the formula. Okay, so I'm going to use the vertex formula. I'm going to find the x-coordinate first. The x-coordinate is this right here. Okay, I'm going to rewrite this formula down here just for our sake of our notes. Okay, so we've seen this before. So it's negative b over 2a. Now what is b and a? It comes from the standard form. So the a is in front of the x squared, so in this case a is 3. B is minus 6x, so it's minus 6, and then C is 5, which we don't need right now, but we're still going to identify it. Okay, let's go ahead and find the vertex. So the x-coordinate of the vertex is h equals negative b over 2a. So h equals negative b. What's b? B is minus 6. So if I do negative negative 6, what happens? I get positive 6. Over 2 times a. What's a? A is 3. Okay, let's simplify this. That's 6 divided by 2 times 3 is 6. So 6 divided by 6 is 1. So what is this in our vertex? That's the x-coordinate. So I know that my vertex is going to be 1 comma something. Now how do I get the y-coordinate? Okay, to get the y-coordinate, I just take this x is 1 and I plug it back into the original equation here and here. Because the vertex is hk, sometimes we like to write k equals. If you would rather write y equals, that's fine too. So I'm going to say k. Actually, no, let's not do k equals. Let's do f of 1. Since this is called f, I'm going to plug a 1 in. So f of 1. Or you can write k equals, or you can write y equals. Okay, so it's going to be 3x squared minus 6x plus 5. And then everywhere the x is, I plug in my answer, which I just got 1. Okay, follow your order of operations. So I got to do the exponent first. 3 times 1 is 1. So this is 3 minus 6 plus 5. So negative 3 plus 5, I get 2. That's the y-coordinate of my vertex. So my vertex is 1 comma 2. Okay, I'm going to go ahead and graph 1, 2 on the graph. 1, 2, that's up here. Okay, that's the center of my parabola. Okay, step B, draw the axis of symmetry. Now I don't have a parabola, but I can still draw the axis of symmetry because the axis of symmetry always goes through the vertex. It is a dashed line because it's not part of the graph, but it does help our graph. The equation for the axis of symmetry is always x equals because it's vertical. What does x equal when I go through the vertex? Well, x equals the x-coordinate, which is 1, or I can look at the graph. So x equals 1 is the equation for the axis of symmetry. Okay, now the y-intercept is also helpful. What's the y-intercept? Okay, if we look above, the y-intercept is 0 comma c. And that's because if I plug in 0 here and 0 here, I end up with 0 minus 0 plus 5. So my c value tells me my y-intercept. And I'm going to make a note. That's my c value. Since my c value is 5, my y-intercept is 0, 5. So I'm going to graph 0, 5 on my graph. 1, 2, 3, 4, 5. Okay. What else can we do? D, plot the point symmetric to the y-intercept and any additional points. Okay, this is my y-intercept. Symmetric means it's going to be a matching point across the axis of symmetry. This is the axis of symmetry. So if there's a point over here, there needs to be a matching point over here somewhere. But I need to match it exactly. So in this case, this is 1 point from the 1 unit from the axis of symmetry. So if I go on the other side, 1 unit, there should be a matching point, and that's called the symmetric point. Okay, now this is enough points to get a decent parabola. I'm going to make sure it's curved and everything else. Let's draw it, and then we'll just check our graph real quick. Okay, so this is a good, make sure it's curved. We don't want it to look like absolute value. Now this is enough information to get a good graph. If I want to check my graph, if I go back here, my A value is 3. So that tells me a couple things. One, it told me it's opening up, which it is. It also told me it had a vertical stretch of 3. So if I go from the vertex and I go right 1, I go up 3, left 1, up 3, which matches what I had. So I think that I did it correctly. Okay, go ahead and try the practice problems. We're going to do all the same steps. Unpause when you want to check your answers. Okay, for number 1, my vertex is 2, -2. Axis of symmetry is at x equals 2. My y-intercept is 0, 6, and I graphed it over here. To check my answer, since A is 2, it's opening in the upward direction. It has a stretch of 2, so if I go right 1 up 2 and left 1 up 2, it does look like that lines up with the graph I have. Okay, for number 2, vertex -3, -7. My axis of symmetry is x equals -3. My y-intercept is 0, 2. I did a symmetric point. My A value is 1 here, so this should make a normal shape. It opens up, which it looks like, and if I went 1, 1, and 2, 4, it should kind of match up with the graph I have right here. You don't need those extra points, but they help you make your graph nicer, plus check your solution. Okay, last one. Okay, vertex 1, 7. Axis of symmetry, x equals 1. Y-intercept was 0, 5. I went ahead and graphed it 0, 5. I matched this across. My A value was -2, so this is opening down. And if I go right 1 down to right 1 and left 1 down 2, it matches up with my graph. So I feel good about the fact that this is probably correct. So let me sketch in my parabola, make it curved.